Hello, everyone. You are watching Empowering Women Summit's last day. My name is Kardan Büyüktanır and I am the Vice Chair of IEEE Women in Engineering Turkey. Today, we are with an inspiring woman, Sara Barros. Welcome to. I'll be glad you to be here. I cannot talk.
Thank you a lot. It's a pleasure.
Thank you. I'm going to read her brief bio, then give the word to her. Sara Barros, born and raised in Portugal, living in Netherlands. Receiving his master's in science in electronic and engineering and telecommunications in 2013, having spent her first 3 undergraduate years at the University of Aveiro, Portugal, and her last 2 years at Technische Universiteit Eindhoven, the Netherlands. Her studies culminated with a full-year research project, OFDM, for data distribution in phased array antennas in the collaboration with the Thales Netherlands BW, for which a patent application was filed. After graduating, she continued with the company and joined their surface radar strategy, technology and innovations group in Delft as an advanced development engineer. There she is involved in low TRL research activities related to the development of advanced waveform concepts and modeling of front-end concepts for the next generation radars. Parallel to this, she participates and coordinates integrated topside design studies for several navies around the world, more specifically responsible for the radiation hazard and above the interference analysis. IEEE member and active volunteer since 2009. She has served in several positions, currently acting as IEEE Microwave Theory and Techniques Society Young Professionals Chair, IEEE Region 8 Strategic Planning Committee member, and IEEE Region 8 Young Professionals Past Chair. For 2021, new challenges await as recently elected to become Region 8 Member Activities Vice Chair. On her spare time, she enjoys playing piano, a good book, caring for her plants, and chasing the sun with friends. This is the end of the bio. Now I'm giving the word for you. Your title will be Opportunities for Young Professionals, right?
That's correct. The Thales Nederland. Yeah. Okay, I'll share my presentation. All right. So thank you a lot for the introduction. I think I can skip the first slide after this. My name is Sara Barros. As it was introduced, I work as an advanced development engineer at Thales Nederland. And on my free time, I do a lot of volunteering work for IEEE. And most importantly, next year, I will be serving Region 8 as Member Activities Vice Chair. So this all started in 2011 when I decided, in a crazy move, to leave my sunny country, Portugal, and move to the Netherlands to study at the Technical University Eindhoven. It was supposed to be just 1 year, which became 2 when I stayed to do my thesis project at Thales Nederland. And 2 years became now 9, since they offered me a job there. I'm going to skip the rest because all the positions have already been mentioned. So Thales Group is a very big international company, actually, that focuses on 5 different sectors of research, if you like. We have defense and security, digital identity and security, aerospace, space, and transportation. In defense, Thales designs smart sensors and advanced defense systems to developing collaborative combat and connecting and equipping soldiers on the digital battlefields. Our systems deliver information and give joint forces mastery of action whenever they face decisive moments. Governments rely on Thales to protect their citizens and make them feel safe. This is the area where I work as well, by the way. Then we have digital identity and security. Basically, every time you purchase clothes online or you book a holiday on the internet, Thales makes sure that that financial transfer is secure. And that is incredibly important nowadays with all the transactions that happen online and all the data protection that is required. About very recently, actually, this last year, Thales acquired also Gemalto, which was one of the biggest cybersecurity companies, making Thales now actually the main player in this field. It means that Thales protects over 80% of all online transactions in the world and secures information systems of 19 of the 20 largest banks. Besides that, it also creates cybersecurity solutions to 9 out of 10 biggest internet giants. And it monitors informations for more than 100 customers. As an example, here in the Netherlands, Thales does this for the Dutch defense systems. Then we have aerospace. Basically, every time you travel by plane, Thales has helped make that flight safer, easier, and more efficient. And that happens by delivering and supporting the systems that keep everything running. This is air traffic management, is training and simulation solutions. It's a connectivity in-flight services, so when you're watching a movie in the plane. And it basically connects all the parts of the aerospace ecosystem. For instance, Thales is the #1 provider of air traffic management. Almost 40% of the world's aerospace are managed by Thales air traffic control centers. And it's the 3rd worldwide and the 1st in Europe in avionics. And 2/3 of the aircrafts that take off and land in the world every day use Thales equipment. Then in space, we have about 125 satellites, 3 constellations, and our main contractor is our Thales Alenia Space. So everything, okay, you know how satellites work. So browsing the internet, calling our friends, basically staying connected during these COVID times. That's thanks to systems like this. Then we have transportation. So every time you travel with public transports between countries, cities, across continents, there's a very big chance that Thales has a role in that. So they deliver several solutions to public transport companies. And for instance, in the Netherlands, and I think only the Netherlands and Denmark offer such a service, there's a single card throughout the whole country for all the transportations, all the public transport. So for instance, for me, I have one card that allows me to use the train, the metro, the bus, anything that is public transport related, even a ferry. It's all with the same card. And Thales does this, for instance. All right. So if we look at the numbers worldwide, Thales has more than 82,000 employees. It's all over in 68 countries and spends more than 1 billion euros on self-funded research and development. Our sales last year have been 18.4 billions. And this year, even though we have these COVID times, the picture is still looking good. And basically the way it works is within these 68 countries, each country will focus on one of those different areas of research that I mentioned just before. Now, how come Thales in the Netherlands exists? Actually, our company here in the Netherlands, it was not Thales before it is Thales. So our company is actually almost 100 years old. And it was founded in 1922 in Engelo, which is a very small town on the other side of the country. And it was called Signalapparaten. And this company was founded for the development of naval systems. So what we do, the research that we do today is still the research that we started doing 100 years ago. So the knowledge that is inside a company is really, really specialized. In the 1940s, during the time of the World War, the company was captured by the German army. And actually, during that brief time when it was captured, they tried to focus not on the development of naval systems because they didn't want to help the German army, but they focused on the development of sewing machines, which also required a lot of mechanical precision, which at the time, all the radar calculations, they were done also with mechanical systems. So they used the knowledge they already had and the manufacturing of these mechanical systems to do something that would not benefit the German army in that way. Then in 1956, most of the shares of Signalapparaten, they were sold to Philips. And eventually Philips became decided that they didn't want to do defense anymore. Then in the 90s, it was bought by Thomson, and eventually in 2000, Thomson became Thales. And that's how Signalapparaten, with 100 years old, now belongs to such a big international company, Thales Group. So this is the figures in Thales in the Netherlands. Only 11% of our activities are non-defense. Everything else is defense-related. We have over 2,000 employees spread across the country, basically in 5 different cities: Hengelo, Huizen, Delft, and Rotterdam, Eindhoven, and Breda. Me in particular, I'm stationed in Delft. There's more than 100 million dedicated to research and development, 300 million experts. It's a lot. It's a big company. Over the years, radars have developed quite a bit. And if you look at the portfolio that Thales has, you can see that also radars can have very different applications. And depending on the applications and on the features that they have, they can be used on ships that have different types of missions. I'm sorry for the background noise. My puppies are going a little bit crazy. So the latest radar that we have put out on the market is this SmartL. That is a search radar, actually, that can see over 2,000 kilometers away. We are super excited about that. Besides that, Thales also offers a Tacticus combat management system. So basically, every time you have a naval ship, that ship has several systems that need to work together. And it's software like Tacticus that allows the operators on board to make their decisions and all the actions. So which systems to engage when, depending on how their surroundings and the threats that are coming to the ship. Tacticus is used in over 160 ships, from small patrol crafts to full-size frigates and destroyers, and is operated by 20 different navies. So it's quite well spread. And some of these include the US Navy, as well as navies in Asia, Europe, Gulf, Latin America, Middle East, and North Africa. Then in the Netherlands, we also have SOTAS communication systems, which is consists of a family of modular components that can be assembled and scaled to provide optimal system configurations for all types of deployments. These can be used for both civil and military applications. It basically provides a great flexibility and logistics advantages for supporting the broad spectrum of applications. And it enables Thales to deliver tailor-made solutions to every customer. Then we have also identity documents and solutions. And this part has really grown since we have acquired Gemalto. So right now, Thales is contributing to 40 national EID programs, and in Europe, in the Middle East, in Africa, in Asia, and in Latin America. I was I checked before this presentation if Turkey was there, but I haven't. So there's basically more than 30,000 actually organizations that rely on Thales solutions to verify the identities of people and grant access to digital services, analyze vast quantities of information, and encrypt the data. And of course, as the world becomes more and more connected, these type of services become more and more important. Then there's a very tiny part of the research in the Netherlands that focus on cryogenic coolers. This is done in Eindhoven. And even though it's a very small part of what we do in the Netherlands, Thales is European leader in this type of supply. Okay, I'm not an expert in cryogenic coolers, so I'm going to move on. And then I've spoken before about transportation. So transportation is here in the Netherlands is based in Huizen mostly. And here you can see one of the machines where we can sign in and out in the Netherlands with our single card. And yeah, so Thales does this, of course, not alone. It works with 7 other different partners. And yeah, it's a really, really good system. Then, yeah, then we have SOC-NOC, which is SOC stands for Security Operations Center and NOC stands for Network Operations Center. And this monitors all the customers' IT and OT infrastructures 24/7. And since IT/OT assets in this new SOC-NOC center are monitored from the Netherlands, data remains in the country and sensitive information is viewed only by screened personnel. And yes, it currently analyzes all the anonymous transaction data from public transport companies, and it ratifies when it's necessary. So Thales in Delft, that's where I work. It's basically a small research group that works under a bigger naval group that is stationed in Engelo. And in Delft, we are about 15 people. And it's more low TRL level research. So that means that we work mainly on the development of new concepts and new ideas that could be eventually implemented in future products. So that's a part of new processing and waveform concepts. There's also another big part, which is integrated offsite design, which is less of a research oriented activity, but more of a service activity to the navies. So every time that the Navy is putting out a new frigate or a new ship to use a new prototype, they need someone that does the integration of all the systems that are going to be on board and does this in an optimized way such that all the systems have as much performance as they possibly can. In my case specifically, I work in integrated topside design. I work also on the classification of small, slow-moving targets based on micro-Doppler signatures, and I work on advanced waveforms, so looking for new waveforms that could be used on radar technology and on new front-end concepts that could be also used in our future products. So I'll start just by talking a little bit about IPD. So basically the whole suite can be comprised of radars, communication systems, optical systems, and all these systems, when they are sold, they have their specs in a free space environment, so they all have great performances. But then you go and you put everything on board of a ship, and suddenly the story is totally else. So not only do the systems itself interfere with each other eventually, but also the structure of the ship itself contributes to loss of performance. And the focus of these integrated topside design studies is to, together with the Navy and all the stakeholders involved, find the best optimized design suite, not only for the systems, but also for the mission of the ship and for the utility that the Navy requires. To do this, we use several different tools. We have a tool here on the bottom. It's called Ruffians, where you can see, basically, you see a matrix with a lot of colors. You have all the victims and you have all the sources, so all the systems that can act as a source and all the systems that can be victims when those sources are transmitting. And then based on the color, we can identify, okay, is this just a bit of saturation or loss of sensitivity, or is there just are things going above the susceptibility level of the systems? And then we can go really into detail for each of the interactions, exactly what is happening. Is this two harmonics? Is this in the same channel? What is happening here? Then on the left, you see on top an image with red, green, and blue. Those are coverage pictures that we can also make in this tool, which allow us to position systems like guns or communication systems with the required coverage that they need. It also allows us to see, okay, if two systems are supposed to work together, we can look at the combined coverage and see, okay, even if one doesn't have the entire coverage that it needs, when it's combined with the other one, they together have full coverage. Then on the bottom left, you see some pink isosurfaces that basically shows us, we can see the levels, okay, basically everything that is colored in pink, then the EM field would be at a certain level. And that allows us to know if there are certain systems inside those isosurfaces that we know, okay, this system has only been tested until a certain susceptibility level, then we know, okay, we might have a problem with the system and we need to move it or do some power management or frequency management to solve that. And then on the right, you see results from a different tool, which is using ray tracing techniques, and basically allows us to see all the contributions of the sieve structure itself. So we can look at all the reflections, diffractions, and combinations of such that occur on board when a certain radar, for instance, is transmitting. And based on that, we can see if there's any coupling issues in between radar phases, or we can see if there's any significant changes in the antenna patterns of our radars. Are we going to be detecting false targets as a consequence of it, and so forth. This is, for instance, how an interactive session would look like. So we basically have our client and we have some screens where we can show exactly the tools that we use. And together with them, we can move systems in real time and we can see what happens in the matrix and make decisions. These are incredibly important because they make the process a lot faster. We can make a preliminary study, but then we always need a couple of these interactive sessions so that we can fine-tune the design with the customer. So what is radar in the end? Because I want to explain or touch a little bit about microdoppler classification. And in order to do that, since I don't know the level of knowledge on radar of the audience, I thought it was a good idea to just make a brief introduction. So radar stands for radar detection and ranging. And it's an electromagnetic system that allows for the detection and location of objects, basically. What is the advantage of using a radar is that it basically gives you more information than your sensors do, and because it can see independent of, let's say, the environmental circumstances, up to a degree, of course. You can always argue that at some point rain, snow, etc. will also have an effect. And it can detect at much greater distances than other sensors. Depending on the radar you're working with and how it's designed, you can get quantitative measurements in range, azimuth elevation, radio speed of the targets you're trying to detect or track, and its special spectral characteristics. You can have different types of radar. I mentioned the SMARTEL before. This is a search radar, for instance, so you can have search radars. These search radars are usually used to see at a greater distance, and they give you a picture of your surroundings, and you can eventually do some level of classification of the target. But it's basically to say, okay, there's something in the horizon that is going to come. Then you have tracking radars. For instance, STEER is a tracking radar that works at a closer range, and it's basically when you already identified that a certain target is a threat or can potentially be a threat, then you want to not only know that it's there, but you want to track it. And then you want to decide what to do with it. And that's where multifunction radars also work. And these tracking radars, they are often connected with other, let's say, ordnance systems that can act when the operators make the decision that that target is a threat. And that decisions can, for instance, be made through software like Tacticos that I mentioned before. So in Tacticos, the operators will be able to see what STEER or what the tracking radar is looking at, and they could see eventually the classification that is given for that target, and then they can make a decision based on the behavior of the target, based on their knowledge of the circumstances, the surroundings, the area where they are, and the potential threats. They can make a decision whether to activate any ordnance system or not. So when you look at the radar, this is a very high-level simplified view of what would be inside. You always have some sort of electrical and mechanical stabilization of the radar. So you have to think that these systems, they are placed on ships, and the sea state is not always calm like we wish in our vacations, but sometimes it's also very stormy. So we give different, we classify it as different sea states, and depending on the sea states, you can have different pitches and rolls of your ship. But your radar, it shouldn't be moving like that. Otherwise, your estimation of where your target is and the tracking of the targets would be constantly changing, and it wouldn't be reliable. So you need some sort of stabilization of your radar to be able to have a proper detection. So this is always there. And then you have a transmitter that allows you to send something that should be returned by the target, by your receiver. And then you have some signal processing, some extraction, which is made on the signal that you process. And then depending if you have a tracking radar or not, you can have some tracking. So most of you probably know Doppler. And this is a very common example of the Doppler effect. I'm not hearing anything on my side, but I hope you are. So basically, you hear that the sound changes as the train passes. You feel the same when an ambulance goes through on your street, and it starts by sounding something, and as it moves away, the sound changes. So this is known as a Doppler effect, which means that when something has a certain velocity, it can have also a certain frequency shift over time. Now, what we can use for classification, so this Doppler effect allows us to know, for instance, the velocity of a certain target. If you have a target with a body that is traveling at a certain velocity, we can estimate the velocity of this target by knowing its frequency shift. Now, if we want to classify targets, we want to look also at other types of movement that occur around the body of the target that make the signature of that target. So you can think about a drone or a bird or a person walking. So we have our main body, and that body walks at a certain velocity. But then you can also have your arms moving and your legs moving and your hands moving. And all those, let's say, parts of your body that are moving, they are moving with respect to your main body at a certain velocity as well. And that's what we call, let's say, the spectral signature of a certain target. So all those micro motions that are close to the body, that go with the target, but that can have different frequencies. So, for instance, here we see a rotor. That rotor is it's rotating, and as it rotates, its tips have a certain radial velocity with respect to the radar. Right now, the rotor is aligned with the radar, and that means that there's no radial velocity that is read from the radar point of view. However, as the rotor moves, these blades, they have a certain return, and that's what you can see also on the right. So on the right, you can see those orange flashes. That's basically when the two blades are aligned and perpendicular to the radar. Then you have many of these scatterers, so of these points that have a certain return, and that gives that flash, and so on. You can do this for several. So every target that has different components will have a different signature. And in this case, we see an example of a human running. And you see that there's a lot of different spectral responses. So when you read velocity, velocity can be associated to frequency in the expression that we've seen in the previous slide. And that's why we call it velocity over time, but you can also think of range Doppler images. And here you can see all the movements of the human body, and you can see a dark red line that not the one at zero velocity, but the other one. And that's the main body of the person. And then you have all the other contributions that have a weaker signal, because also your arms and your hands, and they are smaller components with respect to your main body. And you can see how they behave with respect to the main body of the person. Now, all of these targets that have certain rotating or moving parts can have different signatures or fingerprints, and these can be used for classification. So in this slide, you see different examples for a bird or for a wind turbine, for a person that is walking. So these, when we plot the velocity over time, we call them spectrograms. And through the analysis of the spectrograms, then we can develop classification algorithms that allow us to know is the object we are seeing with the radar a bird or a drone or a wind turbine, and then based on that decide, is this something I want to act upon or not? This is an example of a measurement we've made. So here you see a bird fly. So you see the main body of the bird. You see some things around zero velocity. That's what we call clutter. So that's everything around that is not moving. And you see the micro motions around the main body line, which are basically the wings flapping, among other things, of course. But the ones that you see the strongest around the red line that is not at zero velocity, those are the wings flapping. And what you see is that for different birds and for different sizes of birds, you will have different spectrograms, so different fingertips, different signatures that allow us to know which type of bird it is. This is another example. This is a cluster of birds. And here you can see that there's a lot more confusion about what's going on. So you don't have anymore a single line. You have basically a blur of a lot of things happening. In some moments, you can distinguish different lines. You can eventually see the different birds, but for most of the time you can't. And this is also one of the classification challenges, how to deal with groups of birds or groups of drones. How can we differentiate those targets? How can we act upon them? So why did this become an issue in the first place? So basically before, you could have some sort of classification based just on the radar signature, on the radar cross-section of the targets. So that's just how big a target appears to you. And what started happening is with the development of these new very small drones, the RCSs of these drones, these radar cross-sections, they have about the same magnitude as birds or bats and other small objects, which means that if you would just use a conventional detection threshold of just saying, okay, anything that is below this radar cross-section, I don't mind because it's likely not a threatening target, you can no longer do that because all these mini and micro UAVs, they might fall there too. And that's why micro-Doppler classification of such a targets became a thing. And it's especially tricky to do such when you have also a very bird-rich environment in which you have to differentiate between all of this. So this is an example, for instance, if you would not have this sort of classification, what it would look like when you're looking around in a bird-rich environment where you might also have mini or micro UAVs. And as you can see, I mean, it's just a bunch of points. You cannot really distinguish, is this a problem or is this not a problem? And here you can see side by side, for instance, the spectrogram of a bird and a spectrogram of a mini UAV. And you can see that one of the things that contributes to this classification challenge is that the flapping of the bird wings have a very similar behavior to the rotation of the mini UAV rotors. And so distinguishing between these two is, it's a topic of interest. And here we have just some more examples of when you have more rotors or just one rotor. So when you have one rotor, you have a very clear picture. But if you have, for instance, an 8-rotor UAV, then it becomes really difficult to identify what's going on. And then we can use techniques like not a spectrogram, but a capstogram, which is like doing the same thing twice in a way. And that gives us different lines, and those would be the rotation speeds of each of these different rotors. So we can extract a little bit more information by doing so. In this case, we see, okay, if we do use such classification methods, then we can distinguish in that blur of points, the points that would be mini UAVs or not. And then enable the operator to make certain decisions. And this is basically the same, but in a different view. So I just wanted to give you a little bit of 2 examples of the types of researches we do, and that I can talk about openly in a presentation. What is interesting about Thales, at least for me, is that because here in the Netherlands, we do the whole development of the product, basically from new concepts to testing in prototypes, to the assembly of the product itself, to the sales of the product, to the sea trials with the navies on board. So we have people that go 2 months with the Navy to really be there to see that all the systems work properly. There's room for all types of engineering you can think of, and even other skills outside of engineering. And I'm at least really happy that I can really see what happens to the product in all these stages. and that you can talk with all these people and really basically broaden your knowledge on other areas of interest that not yours. And so this to say that we are hiring. We are always hiring, actually. And if you want to know more information about Thales, you can contact me, or you can go to thalescareers.nl and you can see the openings that we have. And if you're a student, we also offer internships. If you already finished your master's, but you don't know yet exactly what to do, we also have trainee programs that allow you to visit 4 different parts of the company and then decide which one fits you best and go for that. And yeah, I would be happy to welcome you. Thank you. I'm open for questions if anyone has some.
Thank you, Sarah. It was very informative session. Even though it's my...
I'm not hearing you. Wait.
Not hearing. Can you hear me now?
I cannot hear you.
Oh.
No.
Can you hear me now?
No.
Oh. What is happening? Oh. My voice is open. Oh. Let's try it one more time. Can you hear me now? No.
Okay, I can hear you now.
Yeah. Okay.
Yes.
Can you hear me now? Okay. I was saying that it was a very informative session, even though it's not my topic. I learned a lot about the radars that I didn't know. And I didn't know that in Turkey there is a Thales company. It is not big as the Netherlands one, but it was, as I searched for the internet, it is a small company. I want to ask you one question. If I'm working in, I don't know, United States Thales company, and I want to go in another country's Thales, if I can go any translocation with that companies, or they are not working with together? They are different companies, or...
Yes, I understand the question. So we do offer some exchange programs. And we have platforms for that. So we actually even have a kind of, it's not a Tinder matching for companies, but kind of. So you basically have profiles that are open in different Thales companies, and you have your own profile, and then you can see if there's a match if you want to do an exchange. And the tricky part of it is, like I mentioned in the beginning of my presentation, different parts of Thales, they work on very different specific research topics. So the exchange program works, but it works best, let's say, if you're not a technical person. If you are a technical engineer like me, then it would be difficult to find radar research like what I do in another Thales facility. But if you are in sales, or if you are in, I don't know, like ISD, like informatics support, or if you are in the legal department, or these sort of things, which are basically, you can quickly learn how to adapt your skills to a different product, then I think the exchange is a lot easier, and that is possible. Yes.
Okay, I get it. They're working as not the same project, but the different project, so that we need to specify that project in order to work in that company. Also, you're working in defense industry, right? Not you, but you tell us. In some companies, not the nation, they don't want to be working in the defense industry. Not the national, they want to work with the citizens, let me say. And is it in the Thales, when I come in a Turkish woman, I can work in a defense industry project in your company?
Well, this is something that you always have to check with the human resources. Yes, I have to be honest about that. Turkey is a very special country in that sense, right? Because you're a little bit with one foot in Europe, one foot in Asia. So this is something that needs to be checked on, let's say, person-to-person basis. There's always a very intensive clearance check, even for people that are from the European Union. So even though I'm Portuguese, I also had a very thorough, let's say, investigation on my profile. And my husband has to go through the same. And if we have kids, they have to go through the same. So it is, that's part of working in defense. And some nationalities indeed will not be, it's not possible to work there. But for Turkey specifically, I have to say I actually don't know, because I see it a bit of a gray area. You would have to talk with the human resources on this.
No, just to ask.
Yes, I understand.
Many of my friends, when they graduated from electronics or the computer sciences, they are trying to go to Netherlands and work there. So that I am asking.
Yes. Yeah. Yes.
A lot of my friends are working in Netherlands right now, but okay.
Yeah.
That's all my questions, and we don't have it in audience questions. We may finish it right now. Let me take your final words and advices to our audiences.
Oh, I did not expect that. Well, I would say to just go for it, whatever it is. Even if you're trying to move countries and you're going alone, just don't be afraid of it. When I moved to the Netherlands, I was 20. I was also alone. Everything turns out okay. If you are involved in IEEE, I would say really abuse the network of IEEE. I think that's something that we don't do enough sometimes, especially when we are younger. We are very much inside our student branch and our local community, and we forget that IEEE is much bigger than that, and that there's so many connections and possibilities by just reaching out. And that's what IEEE is about. It's supposed to be a family that you can reach out to. So do it, and don't be afraid of doing so. Yeah.
Definitely. Good advices, I think. Thank you for being here. Thank you for presenting your specific topic today. Thank you very much.
Yes, very, very welcome. Very, very welcome. Thank you for inviting me.
Thank you. For our audience, we have one more session and one closing ceremony in the Empowering Women Summit 2020. See you on that sessions. Bye.
Bye-bye.